Hello, now we have wave propagation in conducting medium. What is the conducting medium? So before that, we have lecture about the perfect dielectric. So in case of perfect dielectric, what we have seen that conductivity was equal to 0. So here it is conducting medium. Okay. So here conductivity is not equal to 0. So that's why it's written sigma is not equal to 0. So now here in this derivation, we'll find the expression for alpha and beta, where alpha is the attenuation constant and beta is the phase constant. So that we are going to obtain here. So first we have gamma equal to alpha plus j beta. After that, we'll see that how we'll obtain the value of alpha and beta. So I welcome you all in this lecture of wave propagation in conducting medium. So let's start. So already we have seen that general wave equation in case of conducting medium. So there we have del square E equal to mu sigma dou E by dou T plus mu epsilon dou square E by dou T square in terms of electric field. Similarly, in terms of magnetic field, we have del square H equal to mu sigma dou H by dou T plus mu epsilon dou square H by dou T square. So in the perfect dielectric, what we have done, dou by dou T we have replaced by j omega. Similar thing here also we are going to do. Okay. So here we have two terms. In the case of perfect dielectric, that was the only one term in the right side. So now in this first equation, if you replace dou by dou T by j omega, so here what we'll have del square equal to mu epsilon into j omega into E plus mu, this is the mu sigma, here mu epsilon. So dou square by dou T square, so j omega will come 2 times. Already we have discussion about this. Okay. So now here again further we can simplify. So here if you see that we have common j, mu and omega. So j, mu and omega we have taken. So what we got here? Sigma E. So sigma now we are writing plus from the second term we have j omega epsilon E. So finally E is taken outside. So finally, you are seeing that this conductivity term is going to increase by another term, that is the j omega epsilon. So now this term we are going to write as the gamma square. So finally now we have del square E equal to gamma square E. So now gamma is what here? J mu omega into sigma plus j omega epsilon. That is written here in the equation 5. So now thus this equation 3 and 4 here we can write in the form of Helmholtz equation. Okay. So now this conductivity sigma has changed by the value sigma plus j omega epsilon. So this sinusoidal time varying electric field and magnetic field. Now previously what we have till now it is in the space domain only. So to obtain the time varying, we have to multiply by e to the power j omega t, and after multiplying with e to the power j omega t, we are taking the real part only. So finally here, and this omega is the angular frequency that is in the radian. Okay. So now we are going to take the help of the Maxwell equation. So that Maxwell equation, if you're able to remember earlier, we have del cross E equal to minus dou V by dou T. And B is what? Mu H. And this dou by dou T we are replacing by j omega. Or one step you can add here, minus mu dou H by dou T. Since B equal to what? Mu H. So finally now we'll replace dou by dou T by j omega. So minus mu j omega into H. Okay, j omega into H. Similarly, we have another expression del H square del cross H equal to J plus dou D by dou T. So J, already you know, it is the sigma E, conduction, current density, and dou by dou T we are going to replace by J omega, and D is the electric flux density, that is the epsilon E. Okay, so that's why we got the equation 8, 9, and here del dot D equal to 0 and del dot H equal to 0. So this del dot, already this expression we have del dot D equal to rho V. So now here we are considering that inside the conductor charge density is 0. All charge is going to appear on the surface. So finally it can be written as epsilon into del dot E equal to 0. So that's why we have del dot E equal to 0. And already we have del dot B equal to 0. And B is what? Mu H. So finally it will become mu into del dot H equal to 0. So like this we are able to get the equation number 8, 9, 10 and 11. And we have another identity. This one we have used many times earlier also. Okay, if you have del cross A, again you are going to take the curl of that del cross A. So we have del into del dot A minus del square A. Okay, so now finally we are going to take the curl of the equation 8. So that we have del cross H sigma plus j omega epsilon into del cross E. So now we'll use the equation number 12 here. So by that identity, we are able to write del into del dot H minus del square H equal to sigma plus j omega epsilon into minus j omega mu H. Okay. So now here in this expression, del dot H equal to 0. So this will become equal to 0. So finally we have only minus del square H. And the right side, just we are trying to simplify this. So we have negative j omega mu into sigma plus j omega epsilon into H. So after rearrangement, now we have del square H equal to this value. Okay, and this one is taken as here. Again, same we have discussion earlier. So this is taken as the gamma square. So del square H equal to gamma square H, where gamma is what? Alpha plus J beta. So same thing we are going to do for the del cross E also. Here we are going to apply the curve. Again, we are going to use the identity in the left side. Okay. Again, by the help of that, you have seen that del dot E equal to 0. So finally, we'll able to write this equation. Okay. So now again here, del square E equal to gamma square E. So similar situation in the both case. We have del square H equal to gamma square H, and we have del square E equal to gamma square E. So gamma is what? This gamma square is j omega mu into sigma plus j omega epsilon. So now it will take gamma. So this square root will come right side, and it will come with the plus minus sign. Since minus 1 square is also 1, plus 1 square is also 1. So finally, here we have at last gamma, that one we are taking as the alpha plus j beta. So alpha is the real part, or also called as the attenuation constant, and beta is the phase constant. Now here we have alpha plus j beta. Now we are trying to find the value of alpha minus j beta, so that we are trying to simplify the linear equation of two variables. In the same way, we'll try to simplify here also to obtain the value of alpha and beta. So now by using equation 15 and 16, okay, so that relation we are going to use here. So negative of real part of gamma square is going to be equal to beta square minus alpha square equal to omega square mu epsilon. So finally, you are seeing that here we have beta square minus alpha square. And here we have beta square plus alpha square, that is the modulus magnitude of the gamma square. So now here if you are going to add these two equation, so alpha square will be cancelled, we can get the value of the beta. Okay. So similar way, again, if you put the value of beta, you will get the value of alpha from any one equation, either 17 or 18. So finally, here this equation alpha and beta at last after you are going to derive also, even though you need to remember for the numerical purpose. So alpha is what? Omega root under mu epsilon by 2. Again, here we have root. Okay, square root is again inside. So 1 plus sigma by omega epsilon whole square. Okay, and here this minus 1 is here. So this is under the first square root. Okay, for this one you can write in this way. So this sigma by omega epsilon, this only we are going to compare from the starting onwards. In case of perfect dielectric, sigma is much smaller than omega epsilon. In case of conducting medium, sigma is much greater than omega epsilon. So these two relation we are considering from the starting onwards. So in case of alpha, here we have minus 1. In case of beta, we have, in place of minus 1, we have plus 1. So that is omega root under mu epsilon by 2. And again, you have a square root inside this. So 1 plus sigma by omega epsilon is square plus 1. Okay. So this plus 1 is without the square root. It is only under the square root of the first one. So that is our equation number 19 and 20. So already we have beta equal to 2 pi by lambda and phase velocity, frequency into wavelength, and we have seen if you substitute the value here, what we have f into lambda, so this one we can write f upon 1 by lambda. After that, numerator and denominator both you multiply with 2 pi, this become omega, and this become 2 pi by lambda, that is what? Beta. So finally, we have omega by beta, and the ratio, already we know about the refractive index. The refractive index of the any medium is equal to the velocity of the light in, okay, that is the velocity of the light in the free space, okay, and divide by velocity of the light in that medium. So velocity of light in the free space is what? C. And velocity of light in that medium is taken as the BP. So finally C by BP is what? Refractive index. So value is substituted here. C, velocity of light is what? 3 into 10 to the power 8 meter per second. So now this wave equation for informed plane wave propagating in the z direction, we can write in this format. Again, we are going to compare similar component. So dou square Ex by dou Z square equal to gamma square Ex, and similarly for the Y components. So this Y component is given here as e to the, this one we have finally here in this situation, E Y of Z equal to E naught e to the power minus gamma Z. So this gamma is what? Alpha plus J beta. Okay. So it is again now whatever equation we have, it is in the space domain. To convert in this time domain, we are multiplying with e to the power j omega t. Okay. So finally, if you try to simplify this equation here, so we can write E naught e to the power minus gamma z. So this gamma z is what? Alpha plus beta. So E naught e to the power minus alpha plus j beta into z. Okay. And to convert this one in time domain, we are multiplying with e to the power j omega t. So finally we'll have E naught e to the power minus alpha z into, so this is again sign is plus here in between. That means we can write e to the power minus j beta z. And this equation we are going to multiply with e to the power j omega t. So now after rearrangement, you will able to write here this expression. Okay. So here if you see that here we have e to the power minus alpha z. So this e to the power minus alpha z we can take outside. So then we'll have e to the power minus alpha z. So this is the factor by which wave is being attenuated. And here we'll have this E naught and e to the power omega t minus beta z into t. So this j is outside here. So now finally again real part of this we have cos omega t minus beta z. So this is the real part and this is the imaginary part. So here it's showing that wave is being attenuated by the factor e to the power minus alpha z. So that is, and it is being retarded linearly in the phase, since here what we have minus beta z. So finally, what we have seen earlier in case of perfect dielectric, wave was not going to attenuate, so that this factor was not there, alpha was not available. Only we have phase constant. Okay, so that is the basic difference here. Thank you very much. Any doubt is there, you can write in the comment, feel free to ask. Okay, like and subscribe to increase